Okay, so starting with number 11, it says you use the same bar of soap to shower each morning. The bar weighs 80 grams when it's new. Its weight goes down by 6 grams per day on average. What is the equation of the regression line for predicting the weight from the days of use? So in this one, my starting value is 80 grams. My starting value, remember our equation is y equals a, which is the starting value, plus my slope times x. In this case, my slope is -6. It's going down by -6, 6 grams per day. So in this one, this is my equation, but remember we always want to use the words instead. We always have to define those words. So I have the predicted soap weight, that's what that little hat means, okay? The predicted soap weight is that 80 grams minus the 6 times the number of days. In number 12, it says we expect a car's highway gas mileage to be related to its city gas mileage. Typically, you get a little bit more on the highway, you see the increase in slope, than you do with city miles per gallon or gas fuel efficiency. It says, what is the slope of this line? So in A, so this is the line that they give. The slope is 1.109. It's always the number that's in front of your variable. And what that means, we always say, for every 1 unit of x, my y either goes up or down by that unit, like I'm adding that much from my unit. So in this one, for every city mile per gallon, for every one of those, the highway miles per gallon increased by 1.109. In B, it asks to talk about the y-intercept or locate it and then talk about what it means. So in this one, my y-intercept is my start value, 4.62. So what that means is when you travel 0, y-intercept is always when x is 0, if you think about a graph. So when you travel 0 miles per gallon in the city, then your highway miles per gallon is 4.62. Well, that actually does not make sense because you're never going to travel 0 city miles per gallon. We don't start driving on the freeway or at freeway speeds when you're thinking about what this really means. Highway miles per gallon means like you're cruising at a speed on the freeway and you're not having to do the stop and go. That's not possible. We can never have a city miles per gallon of 0, but then have a measurement for highway miles per gallon. So that's why it's unrealistic. In C, it says find the predicted highway mileage for a car that gets 16 miles per gallon. So we plug in 16 city miles per gallon, and we get that the highway miles per gallon is about 22.4 miles per gallon. Moving on to 13. So on 13, it says to use your calculator to help make a scatter plot. So I'll do that on this one because in the last video, if you want to see how to do it on the Statlet that we use, please visit yesterday's lesson in the homework help. I did one on there for you so that you could see it. Now I want to do it on the TI-84 just so you can see it a different way and you can use either tool. You'll go to the Stat button and then you'll hit edit, which is like you're editing a list, and it's going to give you a couple lists here. I need to clear mine out, so I'm going to go up to the list and hit clear and then enter. I'm going to go over here, I'm going to hit clear and enter. You have to be at the top to be able to do that. And now I'm going to put in my new data. So my percent return, I have 74, 66. Oh, you know what? And I'm already catching myself. I'm catching myself because I started to realize that my explanatory response in this one, my explanatory variable, is definitely not percent returned. My X value is the number of new adults. The number of new adults is going to predict how many return. So they tried to trick me here. My X value is actually going to be the lower number, so the new adults. If there are 5 new adults or 6 new adults or 8 new adults, I can predict the next year how many or what percentage of birds will return. So tricky, but the explanatory variable is definitely that lower variable, the new adults. Coming over here to list 2, I'm going to put in the percent return. That's my response variable. Because again, what this problem means is you can predict by knowing the number of new adult birds, okay, how many will return the following year. So we have on this one, 74% returning, 66, 81, 52, 73, 62, 52, 45, 62, 46, 60, 46, and 38. Oops, 38. You'll want to make sure that they line up. So you'll notice that mine line up. If you're using the Statlet, you'll be able to see that as well. Make sure that your values line up. In here, what we have to do once we get the data in is you go back to stat again, but now we want to calculate stuff. We want to go over to calculate. And we're going to go down to number 8. You'll notice there is a linear regression right here. It says linear regression AX plus B, but we don't use that one. We use the A plus BX. So A plus BX is the form that we are using in here. And that's number 8. We hit enter. We make sure that it says list 1 and then list 2, which is what I wanted to say. And I'm going to hit calculate. There is my least squares regression line. I have 84.45 minus, I have a negative slope here, 1.84. What that means here is that the slope is going down. The more birds, so the more X's, remember how we read that, the more X's that there are, the more there are adult birds. The higher that number is, the lower, because we're decreasing on my y-axis, the lower percent returns. So the less or the more birds that there are, the less that actually return the following year. Okay, and you can kind of see that at the end. It's definitely declining. Okay, so that's what I have for A. A says do this on the calculator. I did it, so you don't have to actually draw that. But now we're going to write down the line. So I have the percent of returns is equal to 84.45 minus my slope, my 1.84, times the number of adult birds. In C, it says explain in words the slope of the regression line and what it tells us. So what it tells us is that for each new adult bird, the percent of return goes down by 1.84%. So for each new adult, remember for every 1 unit increase of X, your Y goes either up or down, in this case down by whatever your slope is. For each new adult bird, the percent of return goes down by about 2%. Okay, 2 more. So for number 14, you're given this graph. I'm not loving it. I can tell you that there's so much variation in this data. I can tell from here that it's actually not going to be a very good line to fit this data. But it says here, calculate and interpret the residual for a student who was 141 centimeters tall and age 10. So the first thing we need to do is to, actually it doesn't. So I'm gonna do a residual. So a residual means, so in A it's saying that a 10-year-old yields a result of 141. To calculate a residual, I have to get what the predicted one was. I know what the actual Y is. Remember that a residual is always going to be your actual value minus your response or your predicted value, like that. So I know my actual value, but I need to get what my predicted value is for that 10-year-old. So I plug in 10 to my equation and I get 148.2. That means we predicted somebody who is 10 years old, and on my graph here, you can see that line right there. If I took a point and put it right on the line, we predicted that kid to be at 148.2. This must be centimeters. Yes, centimeters. Okay, centimeters. So if that's the case, I now have to calculate my residual. I have to think, this kid is actually only 141 centimeters. So this kid is actually going to be lower. So this should be a negative residual. This kid is going to be not quite as tall as we predicted. Okay. I always take my actual value of 141 minus my predicted of 148.2, and I got a negative 7.2 centimeters. So what that means is that we predicted this person is 7.2 centimeters below prediction. In B, it asks for the R value. Well, it actually asks, is a linear model appropriate? I can see the R squared value right here, R squared. So what I did is I took the square root of 0.274, and I ended up with an R value of 0.52. That is going to be a weak association. So I'm going to tell you now, this is not going to be a great prediction line. That's a weak prediction line. Number 15, our last one, we have this plot, and I immediately look at it and I'm like, oh, that's not too bad. That looks like a pretty like moderately strong, positive, linear association. But what they're asking for in this one is a residual for this point right here. If you look at this point, 50 and about 80 right there, so probably that point right there, they're asking what is the residual for that point. It does look to be below. It looks to be below the line, but we don't even need to have that knowledge. In order to get the residual, I already know that they're telling me that the Y value is 80. I have to plug in my X value of 50 into my Y hat. So I already know what my Y is. My actual is 80, but now I need to get my predicted to calculate a residual. So I put in the 50, okay, put in the 50. I end up with a Y value, a prediction of 87.3. The actual was 80, so I do 80 minus my predicted, Y minus Y hat, and I get a residual of negative 7.3, okay? Negative 7.3. So this value is below the line, which makes sense, by 7.3 points.